Hello everyone, welcome you all to today's class. So we are going to study angle between a line and a plane. So if you remember earlier we have studied angle between two lines. So I'm talking about three-dimensional geometry. Yeah, and also we have studied angle between two planes. So, but if we take line and plane, so how can we find angle between a line and a plane? And also, can the line be perpendicular to the plane? What is the condition for that? And if the line is parallel to the plane, what is the condition for that? So let's study all these concepts. Okay, so let me take you to the classroom and I can show you. Yes, so first let me show you the GeoGebra applet. So here you can see. Yeah. So yeah, in this applet you can so as you if you have watched the previous videos in all the lessons in 3D geometry, starting from line in space, specifically skew lines. So I have been using GeoGebra applet so that it is very easy. It is actually easier for you to visualize. Otherwise, drawing the line, plane in the plane. So you will not get that feeling. You are studying 3D geometry. Okay, so here this is the line. Okay, so we can say this is a line L. This is our line L. Okay, and we have this is the plane. Okay, this is the plane. Now here you see, as you can see, angle between line and plane. So this is the angle between line and plane. And as you know, so see, we know how to get angle between two lines, right? The angle between two vectors. And also, when we take angle between two planes, so in that case, actually we find angle between the corresponding normals. I mean, again, we come back to angle between two vectors, right? So we are familiar with that. Now we do not know how to find angle between a line and a surface. So what we can do here, so if this angle is theta, so this will be 90 minus theta because normal is always perpendicular to the plane, right? Now here you see, so if theta is angle between the line, the line and the plane, so 90 minus theta will be angle between the line and the normal to the plane. So it is now very easier for us to find angle between two vectors because we have been studying in that way. Okay. Now let me just take if the line is if the line is parallel to the plane. So in that case, the line parallel to the plane here, line is lying on the plane in this way. So you can see this normal will be perpendicular to the line. Okay. So when line is parallel to the plane, the line, normal to the plane will be perpendicular to the line. And also if I take the line like this, let me just make it perpendicular to the plane. Just one moment. Okay. I have to make this. So I can move this line in various directions, but I just want to show you if it is perpendicular. So here you see, the line is now perpendicular to the plane. So what will happen? Yeah, it is coincident to the normal, or it will be parallel to the normal. Yeah, you can say it can be collinear with the normal. So when, because normal is perpendicular to the plane, and again the line is perpendicular to the plane. So it means the, suppose this is the plane, if I take, this is the normal, right? So it means whenever you take any line perpendicular to the plane, so the line will be like, you can see it will be parallel to the normal, right? Similarly, whenever you have the plane and the line is like this, line parallel to the plane, so the normal to the plane will be perpendicular to the line. Okay. And in case of two planes, what we have studied? We have studied if two planes are parallel. So it means their normals are parallel to each other. And if the planes are perpendicular, so the normals are perpendicular to each other, right? But in this case, when the line parallel to the plane, the normal will be perpendicular to the plane. And also, if the line perpendicular to the plane, it will be in the direction of normal to the plane. Okay. So you can visualize this. So I hope it is clear. So you can just see, yeah. Okay. So this is the, I can come back to the original position. Yeah. Okay. So this is the angle. You can say, it means basically angle between, when we take angle between line and plane, so what we do, we take, that is the complementary angle. Okay, this angle and this angle complementary to each other. So it means this is the angle. So this is, if this is theta, this will be 90 minus theta. Okay, so this angle, I mean angle between line and plane is always equal to complementary angle of angle between line and the normal to the plane. Okay, so let's study the concept in an elaborative way, and we can see the conditions. Okay, so see here, angle between a line and a plane. So you can clearly see the figure. I can write it at figure 1. So here we are given line. Okay, so this line is given by r equal to, I mean r vector equal to a vector plus lambda b vector, which means the line passes through a point whose position vector is a vector, and it is in the direction of, yeah, it is parallel to the vector b. Okay, and we are given the plane phi given by r vector dot n vector equal to d. So where n vector is the normal to the plane. Okay, so we have seen in the GeoGebra, whenever you take angle between the line and plane, here it is theta. Now angle between line and plane, if it is theta, then angle between line and normal to the plane is 90 minus theta. So we define in this way, angle between a line L and a plane phi is defined as the complement of the acute angle between the line L and the normal to the plane phi. So angle between the line L and the plane phi is defined as, it is the complement of the acute angle between the line L and the normal to the plane. Okay, so it means this angle is complement of this 90 minus theta, right? So we are studying in today's lesson, we will learn that how to find angle between a line and a plane, and also we will be covering the portion condition of a line being parallel as well as being perpendicular to the plane. Okay, so let me take this as theta. Theta be the angle between, this is angle between the line L and the plane phi. Okay, so 90 minus theta, 90 degree minus theta, this is angle between the line and normal to the plane. Okay, normal to the plane. So this is clearly visible in the figure, and also you have seen the GeoGebra how they are complement to each other, 90 minus theta and theta. Okay, so as I have told few minutes back, we are familiar with finding angle between two lines. Okay, so here we are given r equal to a plus lambda b. Okay, this is the line, and r dot n vector equal to d, this is the plane. So when we take 90 degree minus theta is angle between the line and normal to the plane, and line is parallel to b vector. So 90 degree minus theta will be angle between angle between so this is angle between b vector and n vector. Okay, and we know if theta is angle between two vectors, cos theta is a dot b divided by magnitude of a into magnitude of b. Similarly, here we can find cos 90 degree minus theta equal to b dot n divided by magnitude of b into magnitude of n. Okay, or you can say sin theta equal to b dot n divided by magnitude of b into magnitude of n. Okay, so this is the way to find angle between a line and a plane. Now we can see when the line will be parallel to the plane and perpendicular to the plane. So let me just see. So this is the plane, for example, and it is normal to the plane. So if I take, this is the line L, for example. Okay, r equal to a plus lambda b. Now when the line is perpendicular to the plane, so then what about n and b? So if line L perpendicular to the plane phi, this implies b vector will be parallel to n vector. Okay, b vector parallel to n vector, right? That means the line will be perpendicular to plane, means the line will be parallel to the normal to the plane. And you know the condition for two lines to be parallel, their corresponding direction ratios are proportional. The condition would be a1 by a2 equal to b1 by b2 equal to c1 by c2, as we know it. Okay, so where a1, b1, c1, a2, b2, c2 are corresponding direction ratios of b vector and n vector respectively. Similarly, if you take the plane, this is the normal to the plane. Okay, normal, and the line is parallel to, this is L, this is parallel to the plane. So it means when line parallel to the plane, in that case, the line L parallel to the plane phi. So it means L will be perpendicular to the normal. So it means the line will be perpendicular to the normal. So it means your B vector perpendicular to n vector, or you can say B dot n equal to 0. Okay, so B dot n equal to 0 means A1 A2 plus B1 B2 plus C1 C2 equal to 0. Okay, so yeah, so I think the condition is now clear. We can take some questions. We are ready for solving some questions. So first question is question number 1. Find angle between the line x plus 1 by 3 equal to y minus 2 by 2 equal to z minus 1 by 4 and the plane 2x plus y minus 3z equal to 0. The first step is we have to check whether we are given the line in standard form or not. Okay, so first what you should check, you have to check whether we are given the line in standard form or not. Okay, check first, check whether we are given the line in standard form or not. Okay, next one you have to see. So once you have checked it, you can identify B vector and from the plane n vector. So what you have to do here, identify. Okay, now you can see we are having the line equation of the line in standard form: x minus x1 by a, y minus y1 by b, z minus z1 by c. Okay, so B vector is 3i plus 2j plus 4k. Now the plane is in this form, ax plus by plus cz equal to d. Here d equal to 0. It means plane passes through origin. So we want n vector only, that is 2i plus j minus 3k. Now theta is angle between, then we take theta angle between the line and the plane. Okay, so yes, so we have to take sin theta equal to b dot n divided by magnitude of b into magnitude of n. Okay, which equal to b dot n is 3 into 2, 6, 2 into 1, this 4 into minus 3, minus 12 divided by magnitude of b, that is 9 plus 4 plus 16. Okay, so then you are having magnitude of n is 4 plus 1 plus 9. So it means you are getting here sin theta equal to, this is 8 minus 12 minus 4 divided by, this is root 29 into root 14. So this implies sin theta equal to minus 4 by under root 406. Okay, or you can say the theta equal to sin inverse minus 4 by under root 406. Okay, this is the angle between the line and the plane. Is it clear? So directly we are applying the formula. Step 1, we have to check whether we are given the line in standard form or not. So then once we check that, we can identify B and N, and after B and N we can apply formula, then theta. Second question is find angle between the line r equal to 2i minus j plus 3k plus lambda into 3i minus j plus 2k and the plane r dot 3i plus 4j plus k equal to 7. Okay, so here it is the line, equation of the line given in vector form, and also equation of the plane is given in vector form. So we don't have much struggle to find, identify n and b. So b equal to 3I minus j plus 2k. We are given the line in the form of r vector equal to a vector plus lambda b vector. And the plane is given in the form of r dot n equal to d. So 3I plus 4j plus k. Okay, so we can find, yeah, theta, angle between. Theta is angle between the line and the plane. Okay, so you can find here sin theta equal to b dot n divided by magnitude of b, magnitude of n. So quickly we can find magnitude of, yeah, b dot n is 3 into 3, 9, then minus 4 plus 2. Okay, divided by, this is under root 9 plus 1 plus 4. Here it is 9 plus 16 plus 1. So it means you are getting here 9 plus, yeah, it is 7, right? Now here it is 4 plus 1, 5, root 14. Then here it is 17 plus, yeah, it is 26. Okay. So I think it is 7 under root 364. So theta equal to sine inverse 7 by under root 364. Okay, so this is the way you can find angle between a line and a plane. So the last question is, if the line r equal to I cap plus lambda into 2I minus mj minus 3k is parallel to the line r equal to mi plus 3j plus k equal to 4, find m. Okay, so we can identify b first. So it is 2I minus mj minus 3k, and n vector is mi plus 3j plus k. Okay, so we are given the line is parallel to the plane. Okay, so it means if the plane is like this, its normal will be like this. Okay, now the line is like this, line parallel to the plane. So it means what? Your b vector, so this line I may write like this, r equal to a plus lambda b. So here clearly you can see, so this implies your b dot, b is perpendicular to n, or directly you can write b dot n equal to 0, right? If two vectors are perpendicular, their dot product is 0. Now b dot n 0 means we are getting 2 into m minus 3 into m, right? a1 into a2, b1 into b2, then it is minus 3. This is equal to 0. It means 2m minus 3m minus m minus 3 equal to 0. Or you can say m equal to minus 3. Okay. Yeah. So this is the basically the way to solve the questions. Okay. So I hope the concept we have studied today is very, very clear to you. So in case you like the, if you have really learned something, you like the video, do not hesitate to press the like button, right? And also in case you have not subscribed the channel, and it is a request to all of you to subscribe the channel too. Thank you so much.